Sorry for all the problems. My go-to meeting keeps crashing today.
Because you're trying to use it.
Because I'm trying to use it.
We're
using
using
it on the spot. All right. Let's put in the hints. Okay, has everyone read this? The hints?
Yes.
Hints for successful life and expert reviews? Okay, great. Okay, Thomas, you want to talk to this or just want to just read it?
Sure, I can. I mean, it was a 3-week sprint as usual. Again, there was a little bit of we actually planned a little more realistically than normal, but always additional work was accepted to the sprint. I think this is largely due to the fact that the parties, there's external parties adding Jira stories with points. So I wouldn't get too wrapped up around this. As long as the work keeps getting done. I just did this slide for consistency, but I did not bother doing the sprint burn down or the rest of the metrics.
Okay, is David online?
That's our workout done. We can launch into it. Now, since David Boswell couldn't be here, he had a conflict. He asked me to speak to this. So he's been running a number of community steering meetings, and during those, one of the activities is to launch the ONOS Ambassadors program, which is making good progress and good start in various geographies. Another point, community-related point, is that we had our ONOS Easter egg hunt. It was the first such thing, and that was actually a pretty successful event in terms of community engagement. There was a lot of additional traffic on our various media channels, especially Twitter. And there were, I believe, four people who discovered the Easter eggs, and they won prizes for that. Also, the additional phase for the module owner program has been scoped out. And the idea here is to be able to collect metrics for review times and to further assist in identifying potential candidate module owners for the different areas of code. And the idea for collecting metrics is that this will give us information for how, sort of be able to meet certain SLAs as code reviewers, because we want to make sure that reviews don't go very long without, basically they don't go stale without any activity. Also William, and now I do not know how to pronounce his last name. William will be joining us and for 2 weeks in April 18th as a new community role for ON.Lab and ONOS.
Can I give you some?
Okay.
Andrea.
Now, do you have something to add to that, Bill?
Andrea does.
Yes, I wanted just to make a quick update on the ambassador program. We basically will have a first meeting, let's say, powered by this program in Turkey in a couple of weeks. They already started the meetup event, and they will be the first trial for this thing, and they will be like the candidates to see what is there, what is not there, what we can do best, and so that's like the first concrete thing that we will do.
Excellent, thank you. All right, so I think that's it on the community side.
So it's Quiviger.
Okay, thank you. I just wasn't quite sure. Quiviger, okay, thank you.
Okay, platform.
Okay, so basically the first bullet is because I was testing out some dependency between applications, and I found out that the circular dependency basically screwed up our startup, because it simply sat there without noticing anything and just staying there. So actually me and Charles fixed it, and there's a fix on Garrett right now that's pending for review, and we basically don't load any application that is involved in a circular dependency. So if we have 4 applications and the last one depends on the first one, all those don't get loaded, because there's the circular dependency, and we cannot determine how to load them in the correct order because of this circular dependency. So we basically, right now, we don't load them. There could be improvement, but at least right now it doesn't sit there just doing nothing.
Okay, I will report the second bullet. So now the Jersey version what we're using is quite kind of old. So I tried to bump up to the latest version, 2.22.2. And there are some kind of minor API changes. So the developer who gonna use this kind of new version of Jersey need to find some changes how you can make it work on 2.x. And the second thing is existing shared schedule service executor has a problem that once the task has been scheduled by using this executor, once there's kind of exception, then it is just silently eat up all the logs or like exceptions. And also, the field task will never restart it by itself. So I added some kind of logic to capture and also log the exception. And the second thing is that the developer can optionally can restart the field task if he wants. And the third point is we have a new like identifier class, and I refactor a bunch of ID classes, and that costs like that can reduce like 1,500 lines of code. So anyone who wanna implement their own like ID classes can extend this class, so can simplify all the job. That's it.
Okay, cool. Is Madan online?
Yes, can you guys hear me?
Yes.
Okay. So the major piece of work that happened in this space, the last sprint, is enabling storage manager by default. So for just a little bit of background, when we did the dynamic clustering support in EMU, what we did was essentially develop two parallel stacks. The one that is currently based on database manager, which provides all the storage primitive builders, to essentially not interfere with all the different ONOS related activities that were going on. We worked on a parallel stack called storage manager, which is built with the aim of supporting dynamic clustering and all the new features. In EMU, it was still marked as off by default. So the first thing that we wanted to do in Goldeneye is turn that on, and basically see how it works. So that work is now complete. So in master, storage manager is the default option whenever you are creating any of the distributed primitives. The important thing is we have seen significant performance and stability improvements once we turn this on. As an example, I created a simple load test that attempts to measure how many distributed operations we can do on the cluster. The specific operation we do here is incrementing an atomic counter, which is a good proxy for all the different consistent operations that you can do. This experiment, on a 7-node bare metal cluster, we can do upwards of 135K operations per second. Whereas previously, once you hit 15 or around that mark, things would become very unstable. So this is a significant improvement in terms of performance and also stability. And the key thing is this particular number is scalable. If you have a larger cluster, you can do more operations. So that's good in that respect as well. And also other thing that I noticed is the startup times are now much faster. Again, the experiment that I ran on bare metal, you can now start up like all the 7 nodes, everything ready to go in half the time than we were able to do before. So that should definitely save some time, when people are doing this development iterations. And all this was done with 7,000 lines of code. I mean, granted, this was a parallel stack that we put up back then, but the newer code base is much more lean and simple. And part of that was achieved by upstreaming a lot of enhancements that were previously part of the ONOS code base into the upstream copycat project. So again, it helps us, create the right kind of interfaces and also make sure, what we are building is reusable. The other part of work where I worked with Show on this a little bit is, look at some of the issues that we have been having with respect to resource store performance. One enhancement that I made was to make sure if you're doing a two-phase commit transaction, right now we are paying the same cost even if your transaction just updates a single key. So I added a fast path for making sure if you have a single key update in your transaction, we can essentially do a single update. And also I've been talking with Show on how we can better represent the resources so that we have better performance and stability whenever we register a lot of these new resources. And finally, the new distributed primitive. This is work that Aaron has been driving. So I think he has made significant progress in adding a new tree map primitive that is going to provide a slightly different semantic for a map type data structure. Where you can actually now operating on a sorted style data structure instead of a hash style data structure. So overall, those are the updates on the core side.
Nice changes on the storage manager. That's excellent. It's great having that much fewer lines of code too.
Yeah.
Mhm.
Yep.
All right. NP.
Hi.
Hey, Show.
Hi. What I working on this sprint, the first thing is tackling the concurrent resource allocation issue happens when concurrent intents are submitted to the system. The cause of the issue was identified, and I found the workarounds, but the fundamental way to resolve this issue needs significant performance improvement. So it takes time. So currently I don't have enough time to resolve this. So I will tackle performance gain in the later sprint. And the second thing is as Madan already said, I'm exploring the more efficient data structure to have a more performance gain in resource management stuff. And I started the implementation of range-based compact representation of resource set. That's all my side. Thanks.
Thank you, Show. Anybody else on Northbound?
So I can speak to the virtual network stuff. So on a strategy side, I had actually a couple of discussions and meetings with Guru just to make sure that I understood the requirements and use cases, and to also inform Guru of the intended approach, or at least of the prior approach that we started during the Drake timeframe. And we achieved agreement and sort of validated the approach. So what still needs to get done, part of the scope of this, and I just didn't to it, is what we need to do is document that. Why to be congruent with the previous the implementation of the existing system can something that Brian Sankey and Colin
We're losing you, Tom.
are working on, and so they started.
We're hearing about every third word.
It's a cycle.
That's frustrating. Sorry. Is it better?
Heard your name.
Yeah, that's better.
There's Brian Stinky from ONOS, yeah.
Okay. So I don't know where I should resume. Did you hear the first part about the strategy?
Yep, heard that.
Okay, so on a implementation side, like I said, the good news is that the existing approach was congruent with the the agreement that we have with Guru, and so the implementation on a virtual network provider was able to be started, as well as the CLI was added, and then REST API is now currently in progress. And this is work done by Brian Sankey and Claudine Chu from Ottawa. So, so I think that's that.
So in terms of the status of the implementation, um, Brian will have a review available shortly, but he's basically got an intent-based provider that builds tunnels for virtual links, and that's so we actually have an implementation that works pushing rules out to the data plane, as well as storing them in a distributed store and making them available via CLI.
All right, anything else on Northbound?
Thanks.
I wanted to say that I hope there's more design review on the virtual network strategy and design, because I think a lot of people might have worthwhile things to say about it.
Yeah, it's a pretty key part of our system. I agree, Bob. So, Thomas, I'm sure you'll be doing that, right?
Yeah, and then it's part of the high-level approach is going to be documented, and I just didn't get to the number of other interrupts that just got in the way, and so that still will be work that will be done in the coming week or two.
Yep. Okay. Thanks, Bob. Thanks, Tom. All right. Southbound?
Okay, so regarding southbound, first thing is that I implemented the mastership for the netconf devices, and so right now in, let's say, a 3-node cluster, the master has the connection with the device and is the only one that is capable of doing operation with the device. We chose this path in order not to have replicated 3 connections of all the instances, but when the mastership changes, the connection gets established with the new master. And actually implementing it unveiled some limitations of the using the is reachable method and not replicating the state of the device across the cluster by using only the provider method. And I had some discussion with Madan and Thomas, and we will see how can this be enhanced in the future. But right now, I made it compliant with the existing implementation of the mastership, but it contains some workaround. But doing this work helped us discover some limitations. Regarding the SNMP, I did some refactoring in the providers and the protocols. Before, it was kind of all tied in the provider folder, and right now, instead, it is a provider protocol and a new set of drivers for BTI and some for Lumentum, and also change the type of discovery devices of discovering the devices, because before the discovery of the devices was passed via component configuration, but it's actually we provide a NetCFG subsystem. I switched to that subsystem and provide some unit testing for that. And as John said before, we upgraded the REST southbound provider that we used for the eCord project to Jersey, to the new version of Jersey, and changed the probing of the reachability of the devices to a new method using New Jersey.
New Jersey?
New Jersey?
Yeah, the region. We go there, we test the device, and we come back.
Let's hope it wasn't Trenton.
This one is going to be long sleeve.
And that's it.
That's it? Okay. Is there a slide for some of the things you're doing, or do you want to chime?
Well, I have like other
You got a
slides
slide?
later.
Okay.
Yeah.
Okay, performance? Going once?
I guess I can speak to this, but please jump in and help me, Madan, because it's a number of these items kind of relate in your you helped find these. So we discovered a performance regression in the OpenFlow rule adaptive flow sampling feature that's part of the provider. It was an experimental feature that was added in I think in a Drake EMU time frame. And we enabled it by default, I think, in Falcon. And I think there must be some sort of a defect because the whole goal of this feature is to actually improve performance and reduce the load on control plane channels. It appears to have an opposite effect. So for now, what we've done is we've changed the default to disable the adaptive flow sampling by default. And we will most likely work with Sang to investigate and potentially fix this, hopefully as part of next sprint. There were also a number of, as in investigating what's going on, we also discovered and fixed a number of regressions in distributed flow store as well as EC link store. Actually, the EC link store defect was discovered by somebody from outside. And also, as part of this, and we'll cover this as part of REST API, we've added a mechanism to insert flow rules in batches to allow fair comparison with ODL white paper. That's all I have.
Can I add something? So I think that on the other branches we thread so the ICS and published the white papers talk about the comparisons between the ODR and the ONOS. So looks like something is wrong in their setup. They'll get the very bad number for the ONOS. So now we in the week before, we set up a email thread between the Huawei guys and the ON.Lab, the team members, the Suibins, Thomas, Madans, all these are in loop with ICS. So now they'll collect the informations from our side and try to retest in their environment. And sooner they will republish these ones. I hope in the next spring we can focus on the ICS case and see if we can get a better number. So basically, they want to capture the windows, the two events in the futures. One is end of the April. It's layer 1 to 3. So they want to republish the performance data. Another one is in the June. In the June timeframe, I forgot what's that the conference is. So they want to publish in that one. So
who's they?
The Huawei's standard guys, who is the
You say they want to publish. Who's they?
Publish the ONOS performance data.
Right.
Yeah.
Who wants to publish?
Actually, it had published previously
Right.
data.
Yeah.
So I assume this is what it's.
Well, I couldn't tell if he was referring to Ixia, Huawei, or us. When you said
Yes.
they. No, don't say yes. Which one?
Which one is?
Or are you saying all three together publish?
Yes.
Okay.
Yes.
Okay.
Yes.
Perfect. Okay.
We are three. Now there's before they're separate, so they were having to check
even
out
better. Okay.
then they publish.
So
now
with
they
these
will
changes, I think we can get
I think that we also include fix the 700 node, right? So they cannot beyond that. Once they reach the 700 node, so the topologies become unstable, right? So we have the number of link limitation issues. I hope we can fix that part. Yeah. Okay.
Okay. All right. Thomas, are you doing this or is this Ted?
No, I'm online.
Okay.
Yeah, so basically in this first Goldeneye sprint, I've been working on designing and developing a server-side model of the topology view to be shown in the UI, because we want to support more complex interactions, in particular to support navigating through regions and seeing subregions and being able to get an overview of your network and then drilling into areas of interest. So we've got a good design for it. The link is there if you want to see, and I've started implementing the code for this. And then just as a side note, we've also initiated working with a graphic designer to help us update the look and feel of the UI. And this also spills over to the cord because we want to provide a consistent kind of brand identity between the two projects. So that's it.
Thanks.
Okay, this is my part. So, with existing REST API, we cannot use the flow table pipeline. Actually, the underlying, we already implemented this flow table pipeline, but the codec, the REST API codec, does not support specifying the flow table ID in the pipeline. So I implemented that part. The second is I also enable to encode and decode the group table, meter table, and the sequence like ID in instruction codec. And third part is I did some unit tests for merge cast route. And another thing is I found that there are some like classes. Some are under the resource like packages, and some are just same like level and the REST API. So I put to make it consistent, I put all the files that is in the upper side of the REST package into the REST the resource package to make it consistent. And this is all my part.
Good.
Okay, so last one is
What's that, Ray?
I forgot all about the last item.
Okay, anything else? Thanks, John.
Yep.
Oh, what is that last one? Oh, refresh that. Can you refresh that? Or is-
Can I
oh, it
refresh
doesn't
it?
matter. So in QA, we spend significant effort to move all existing intent testing that's using flow services, and also added to having it testing against using flow objectives. So those are all in the functional HA performance scale suites. So all the test case modifications are done, except that we are blocked by a bug that we found is, I think, is a blocker that basically when we enable that, when we run in a cluster, we see stack overflow. And that's being worked on by Jono and Marco. And then we finalized the netconf functionality test. And another big effort is that you'll work on moving our old chode style testing to what we call the chaos monkey testing. So that allows us to dynamically and very flexibly inject any kind of network events, node events, or any kind of checking events. So all the base cases are completed, so we are equivalent to what we used to have. But from there on, it's a lot easier to add more events into our chode test. And we will have a demo at the end of the meeting here. And we talk about the performance testing. Basically, what I consider one is to validate ODR published paper, and we found a couple of bugs and fixed those bugs. Secondly, for the future, we want to use that as a real regression test, because this is a test suite that really tests from end to end, from the very top of the REST core to the bottom of OVS, and will be a very good use for a regression in the future. So there's a plan to do that. And then HA test, we implement the new implementation, using the new implementation of distributed store. And we spent some time working with the Huawei India on building up some system tests on BGPLS and Yang and SFC. BGPLS, they've committed changes. We are reviewing that. Yang and SFC, we need to think about what the real testing strategy should be. So we're in the middle of discussion with them. In terms of the bug status, we opened 22 bugs this sprint. We closed 10 in this sprint. So a net of deficit of 12 added to the overall balance of 110. And I list out a few what we consider blockers. One is the one that we talk about, the Java stack overflow. And then we have the other three has been there for a while. One is that when we do chode, when we do link up and down, we can see some of those intents get stuck in the installing state. And then there's some race condition when we star clusters. That those are the two buckets we have.
And do these four all have someone assigned to them on the development side?
Well, on the installing, the intent installing one, been there for a while. We're thinking that maybe, I don't know when the intent move to flow objectives completed, then we can reevaluate that again. Because the thought was that back then that there a lot of refactoring on intent.
I mean, we have a trial implementation, but we have both implementations.
So yeah, once that's completed, we want to test those against the new implementation on the flow objective and see how it works.
So 3047 is okay on hold until.
Yeah, I mean, both of these things, from my perspective, are in a can't replicate hold pattern.
Okay.
So unless we can find, they can only be replicated in large environments with tons and tons of flows, and so we need to either introduce more logging, collect more data, or find a simpler use case that triggers the same problem. Because without that, it's hard to fix.
Okay, so there's kind of two things. So one is either we expect it to go away, or we're going to waste time because we have new software coming that replaces this functionality, or it's still there. It's just hard to duplicate. Which one is it?
Both. It's still there. It's hard to replicate, but it may go away in the future due to new functionality.
Okay, right. Okay, right. But if it was only hard to duplicate, then I would say we need to spend effort. Yes. Okay, that's what I was after. All right.
The last one, we haven't been able to reproduce for a while, so I think we can probably close it.
Okay, so you can make a judgment whether you want to close it or not.
Yeah, I mean, I haven't seen it in 3 months, and it used to happen like every time I try to start ONOS. So.
Okay. Okay. Great. Okay. I have another question. Oh, so the Huawei test cases are those test cases that are going to flow into our automated into the general automation suite?
That's in the discussion. What is the right thing, right setup to roll into automated suite?
Okay.
So generally yes, but SFC might go to OPNFV because that's also just an open stack.
Yeah. Okay. Makes sense. Okay. Good. Thanks. All right. The buck stops here.
Sure. So Brian and I spent a couple of weeks working with a tool called Buck that we showed you at the last sprint meeting, I think. This is a purportedly extremely fast and efficient build tool from Facebook by way of Google. It's used mostly for Android development, but there have been a few. Garrett is one that use it as a more enterprise kind of build tool. So after some hacking, we got basically everything is building now, and all the unit tests pass. Build times went from about 16 minutes to 2 minutes. Yeah.
What a great return on investment. Huh?
Yeah, exactly. Brian, after much work, managed to get all the OSGI artifacts correct, which means that ONOS now actually runs correctly with the artifacts that we spit out. It was easy to spit out the jars. It was not so easy to spit out OSGI jars. We found a lot of things in our current Maven infrastructure that were either wrong or inefficient, which we fixed as we went along. If they were obvious, if it was more difficult, they just will not carry over into Buck. Large number of sort of superfluous artifacts were also subsumed into other ones, and so we now have a much more sort of, efficiency is the rule of the day, right? That's what we're shooting for here as much as possible. Brian will show you in a minute what these Buck rules look like. If you haven't looked at Buck before, they might look a little weird. They're basically embellished Python. So when you look at these things, think Python, and then maybe they'll make more sense. What Buck calls a rule is actually a Python method. We have a bunch of things remaining to do. We've instrumented a couple of the apps just as a proof of concept. We have to go through and get all the rest of them done. That's pretty manual and not that hard. We still have a few niggling things we have to add. We have to add Swagger, JavaDoc, Sonar, basically anything that post-processes the source. We have to figure out a way to do it in Buck. And I don't know what the last bullet point is.
Oh,
We talked about
so basically right now, ONOS setup graph and ONOS package draw from the M2 repo. The idea is, the last bullet is demo later.
Oh, all right.
The idea basically is we want to draw from the buck artifacts more directly. It'll make ONOS package and ONOS setup graph a lot faster. It'll also take the M2 local M2 repo out of the loop entirely.
So you want to show what the master rule looks like now? Or
So I was
going
going to show the rules during the demo.
Okay,
So yeah, there's
good.
going to be a demo at the
Okay.
end, functionality and just a sort of brief overview.
Okay.
Cool. Excellent. All right, developer tools.
All right, so for some time, oh, this is cut off again. I don't know why. That's annoying.
You were cut off?
The
No, it's the bottom is cut off. I don't know why that is, but it's not cut off on the original slide. Anyway, for some time, Brian and I, and perhaps other people, have been wanting to improve the sort of local development environment to enable you to have bring up an ONOS cluster on your laptop in a quick, easy, and efficient way. And so we're looking at least several alternatives. Prior work, including standalone ONOS cluster using the server class, and this iteration, basically recreating the old ONOS.py, which we had in prototype versions of ONOS, where you had a mininet controller class that could actually start up an ONOS cluster. And that's exactly what I did in the last iteration. So we have a prototype version of this, which doesn't work 100% of the time, gets some exceptions when ONOS starts up, but hopefully we'll be able to do a demo. And the overall goals of this are unfortunately cut off. I don't know why that is. I guess I don't know if I can become the presenter or if you can refresh but anyway, the basic goal is to have a fast, easy, lightweight, distributed, there we go, ONOS development environment on a laptop using a single VM, or maybe in the future, no VMs at all. And to make it easier to start developing for distributed ONOS kernel and applications software, eliminating these sort of bloated, unnecessary VMs and containers, which are overburdening our existing infrastructure and our laptops, and also ultimately facilitating control network modeling, for example, delay between communication delay between ONOS nodes, between ONOS nodes and switches, also link loss, various failure scenarios, making it easy to do that both for development and for testing. And I'll give a demo later.
Great. Okay, thanks, Bob.
All right. Deployments. So thanks to Michele, we did quite a big work to integrate. Well, Michele and the Corsa team, we did quite a great job to make the integration between the intent framework, the flow objectives, and the Corsa pipeline work, which means that now we should be able to run at least SDNIP and SDX layer 3, which is the application just committed by Giant, on top of the Corsa pipeline. And it's a demonstration basically that more in general, the SDNIP application can work with the flow objectives on a multi-table pipeline. I'm working with developers here to integrate SDNIP and BPLS application. So my final goal remains to provide, on top of ONOS, running multiple applications together. And in this specific case, to give the ability to the users to run, to give layer 2 and layer 3 connectivity using two different applications. Mark is, we already started this discussion at the ONS. It became more concrete, and now Mark is in Korea and is discussing with Cryonet about packet optical deployment. In the meantime, I'm contacting new research network. I already mentioned last time that I was interested to do something in South Africa, but there's interest also from Japan and Russia. So I'm starting these conversations. And finally, I'm trying to talk to the guys of before, so Barefoot specifically. It's really just an introduction, but since Carmelo is working on it and he will talk about this to you later, I'd like to bring P4 also to hardware and give it a try and see what we can do together. So I'm starting the discussion with them.
Thanks. Anything happening with the internet too?
No, I keep bothering them with emails, but I guess we need they wanted to make sure that the first thing here was done.
Yeah.
And once we can demonstrate that we run on top of certain devices, they will move forward probably. They're doing lots of stuff to adapting. Sorry, to give you some context. Internet 2, more in general, now it's public, is moving. They decided that it wasn't a good thing to share, to use the same crappy infrastructure. Sorry, Internet 2, but they know that. To run production traffic and experimental traffic with OpenFlow. So the decision is to reconvert the production infrastructure, the existing infrastructure only to production, okay? Possibly, I believe, legacy protocols, possibly. And, or just keep very few things and then build a separate, isolated infrastructure, OpenFlow 1.3, all around the nation to deploy new things like, for example, ONOS and SDN IP. And so this is what is happening. They are in the process of creating the new infrastructure, and we are just talking. But things are moving forward slowly, but we'll get there.
Thanks.
At least we are not the blocking part.
Yes, that's a goal, right?
Right.
So I will explain my part. So this is the report about the control plane manager. So the monitoring part is almost done. So basically in ONOS, we are collecting lots of like matrices, like using metric services, like the number of messages that has been transmitted between East-West API, also number of calls and those kind of details, also the control messages and the CPU load, like those system-related matrices. Those are all like collected, but the problem is there's no way to expose those data to the third-party like monitoring server or like database, so that we can query just by using this one site. So by using this tool, basically what we can do is we can easily monitor the whole like almost the cluster in just one site. I will give some demo later on. And in order to do that, first of all, I implement two reporters in the query app. First one is influx database, like a query and report app. So using this like application, we can expose all the almost like metric data to the influx database in our runtime. And also I implement this Ganglia reporter and the query app as well. Ganglia is the distributed monitoring server, so it's very easy to monitor the whole like almost status. And also, the monitoring part has been done in a CPM. So I initially documented some part of some architecture stuff there, so you can find the document there. And also, I implemented some REST API to expose the control matrices. And I enhanced the metric like database. Currently, it supports only one type of resource, but now it supports multiple type of resources. And for the showcase, I somehow integrated the influx database and the Grafana. Grafana is a visualization tool, third-party visualization. I tried to integrate that to use this Grafana to visualize a whole bunch of almost matrices which stored in almost like each cluster. So I will show some brief demo at the end of this session. Yeah, that's my talk.
Great, thank you.
Okay, so yes, I didn't quite actually plan to put this in the sprint, but I got some time on my hands and I did it. And basically, when we started Refactory SNMP, we discovered the whole problem with the alarm providers and the fault management application. So basically, what we did is refactor the whole subsystem, moving it into a more compliant to ONOS architecture. And right now we have a polling alarm provider that periodically polls alarms from devices. and you can use that. You can set the polling time via component configuration, and that uses the driver subsystem. And if the device implements the alarm consumer behavior, that behavior goes down to the device, retrieves the alarms, and pushes them up to the alarm manager. And so that is done. Right now, only 2 devices implement that are the old BTI devices, that because BTI brought in the whole subsystem, and they implemented the retrieval of the alarms for their devices. I simply moved it to implementing the alarm consumer behavior. So I encourage people to start using this. Is right now is pending for review. I hope to do some internal testing when Mark comes back with the Lumentum devices that we have for the eCord project that are SNMP. And but I encourage people with every protocol. It's not protocol specific, so you can do it with whatever devices you want. For example, if P4 supports alarms, you can use that to provide alarms regarding the device to the subsystem. And I did some unit testing, and so this is a first step forward. And I think that there is still a lot of work to do in the fault management application, because right now, for example, it supports only device-specific alarms. But at least right now it's in a stable and consistent state. We might want to refactor also the polling alarm provider to be an abstract alarm provider. I will have a discussion with Thomas about this in the future. But at least this is a start step that we know that is fit for the ONOS infrastructure and compliant with providers, drivers, and it doesn't set any wrong precedent from that point of view.
Patrick, so in getting more devices to use this, is this something that Huawei is going to end up using? Do you know? Or?
Actually, the fault management is not from Huawei.
No. It was brought in by BTI.
Right.
Yes. Yeah. So I think.
But in extending it, I'm just wondering if Huawei.
Oh yeah,
use this
actually we are talking about the pinpoint project. That is basically doing the similar things, but it's on the virtual machines, all these core architectures. So I think the fault management over here is more focused on the legacy system.
Well, it's not focused on any system. It's simply you can
the legacy, the traditional ones.
Well,
it's the legacy device, right?
As this is implemented right now, it's. You can put whatever you want in the alarm consumer behavior.
Okay,
so
I was thinking this one was tied to the SNMP protocols, right? And from the project, now is you're working on trying to make a common things. Yeah, it's good. So I want to say that we also have another project called the Pinpoint, which is official project in the OPN-FV. So we talked to the Tom Toffees and in the core architectures. Potentially that could be used that ones to detect monitor the virtual environment fault management or something. We can talk about the offline. If both sides can integrate them together, we can share some. Yeah.
I'm just thinking
just to make
it, get a couple of partners to kind of agree on environment fault management, right? And,
no. Just to make it clear, this is not tied to SNMP anymore. Before it was. I moved all the ties with the SNMP stuff, related stuff, in the drivers, so the polling alarm provider can be used for whatever protocol you want. It simply polls for the device, goes for all active device in ONOS, and if that device supports the behavior, it uses it to get the information from the device. We might want to, as I said, provide an abstract to give a more general thing, but at least right now that the full management application is not tied to SNMP anymore and can be used more generally and can be extended and maybe worked upon to integrate other elements. But I think this is a topic for an offline discussion, not right now.
Yeah, good. So thanks for this.
Okay, thanks, Andrea.
So last time I talked to the teams, we are working on the plans. So that we just get the plan down in the OPN-FV release C, Colorado. Their name is Colorado. It's another river. So the mainly focus on the the build and remove chain, and the insert and remove functions into and from. So the third one is the load balancing any of the virtual functions in the chain or the multiple ones. So I think the most of the code we already built into the ONOS, but now therefore in order to meet their OPNFV criteria, we need to retest everything. Okay, so we still have some the development work in the OpenStacks. The OpenStack, what they call the VNF graph. So the virtual SFC's function, official name is a VNF graph. It's in order to differentiate from others. They will only use the service function chaining. So there is the driver code development over there. But after that part is done, so the service function in the OpenStacks can manage the service function tunings. So I really don't have much to say on this part. So we still need to take the 1 or 2 weeks to figure out anything missed in the current ONOS code and try to come back to the teams about what we're to do in the next spring. Okay.
Thanks, Patrick.
So the Indian team is in holiday, so I haven't got their final updates about this ones. The PCEs, I cannot tell too much about this part. Yan, can you go to the next one?
Yeah, I mean,
TV?
no, I'm driving it.
Yeah.
Is that what you're asking?
Oh yeah. Sorry. Oh, you're not.
Yeah.
Sleeping. Okay, the Yan utility. Yeah, now it's still working on the parsers and the compilers, all the things. Now you can take a look at the code. They have a lot of code there waiting for the code reviews. So they already implemented the UT code. Actually, I have one concerns about this one's how to verify tools the correctness, right? In the futures, they will generate not only the translate the Yan to the XML and others, but also they will generate the code how to make sure the code is the tools is correct. I actually had the offline talks with Ray about this. He shared some his previous experience in the SNMP with me. Now I'm trying to figure out the better way to verify this code. If the teams here you have you had experience before and know any tools can verify this, so let me know. So the Yan tools basically it's a useful tools if you build the northbound, the southbound, the translations, compilers, all these things. It's a common tools. So I'm currently think verify this is important. So okay, so there's Yan utilities. Yeah, so the IS is another southbound protocols we're working on. So the Indian team is working on these ones. I don't have much update. So okay, here's all I have.
Okay, thanks, Mike.
P4. So for the concern the integration of the BMV2 software switch, there's a few things. I finally implemented the device provider. Thanks a lot to Andrea, who really helped me, in this task. So now we can discover BMV2 devices using netcfg. I implemented BMV2 model JSON parser. So the BMV2 model is a representation, a structure representation using JSON of a P4 pipeline specification. So this is used to, get some information from the device pipeline, like the tables, fields, the type of match we can execute on the fields, and so on. I did some restructuring of the folders to better separate what concerned the protocol part, the thrift-based protocol part, and the drivers. I did a dependency on for the thrift compiler in the POM XML So there's no need to have 3 pre-installed to build ONOS with BMB2 support. And all these changes are pending review on Gerrit. And I didn't complete, and I'm still working on the mapping between ONOS and the BMB2 model specific for the selectors and treatments. It's almost ready. There's a nasty bug like I hope to solve in the next days. Then for what it concerns the research parts, there's some new documents under ONOS/P4 in Google Drive. I'm trying to formalize some questions and answers on what does it mean to integrate P4 and programmable packet processors into ONOS. And concretely, there's a proposal for what I call Flow Objective version 2, which is an evolution of the current Flow Objective API needed in order to enable the scenario in which we can auto-generate P4 code. And I presented this idea at the AT&T Research Summit, and it seems they liked it. The general comment from AT&T was, we don't care about programming the pipeline. We don't care about learning a new programming language. We don't want to handle this complexity at the data plane. What we want is to program new packet processing capabilities, device-level packet processing capabilities from my level perspective. So, and this proposal seems, to address this concern somehow. And I already sketched the APIs for this objective. Hello?
Could you say that again? I didn't understand what the feedback was that you were just saying.
So the feedback from AT&T was like it seems they don't care that much about P4. So, or in general, like programmable pipelines. So they say that they don't want to, so P4 for them is like it's a new level, it's a new layer of complexity, right? Because if with OpenFlow you just need to install flow rules into a device. With a P4 based device, before installing flow rules, you have to define a pipeline. You have to write a P4 program, right? They don't want to handle this complexity. That was, the comment that I received from the people I spoke with. So they like the idea of like hiding this complexity at the control plane so that you can define high-level forwarding, device-level forwarding behaviors, and then these are compiled into in this case P4 program and deployed down to the switch. So it's all about adding complexity. So for them, it doesn't make sense that the operator like AT&T has to define their own pipeline. They don't care about handling this new layer of complexity, which is complexity for them. I don't know if that doesn't make sense.
Thanks.
Well, for some group within AT&T, it makes total sense, right? That they have abstractions that don't go into this detail, right? It's conceivable that they also have other groups to get new value-added features where they actually would want to go and do some of these functions, but I don't think AT&T is that involved yet in their development teams, right?
Yeah, this was like
one quick question. You see you got feedback about they don't care about the pipelines. So you see they want the high-level programs or the P4 language don't specify the pipelines, right? Or something I lost.
Well, the thing is that when you program a pipeline, someone in the picture have to write a P4 program, right?
Okay.
With a P4 program, you can define what an OpenFlow pipeline is today. So with OpenFlow, this is given to you. Like this is the pipeline. Now you can configure it, like install flow rules. Someone in the picture now is to write a P4 program because the idea is that like when you build a P4 capable switch, like for example POF switch, right? The pipeline might be empty, right? You need to build it. You need to design and deploy the pipeline. So who should be in charge of like doing this, of writing the P4 program? Should be the application developer, should be the vendor, should be abstracted from the control plane perspective. There's different scenarios.
Okay.
So I like the idea of working on what I call Flow Objective version 2, and there's already a proposal in the APIs for this. And I'm still working on the refactoring of the criterion typing scheme, which is needed in order to enable the specification of the definition of new header fields to match up like not known header fields. I'm still working on this. It's almost there. Yeah, that's all.
Thanks.
Can you refresh this?
I can.
Come here to talk.
Near the mic.
For SDMP, we moved the React to routing feature inside SDMP to use a new config subsystem, so the users don't need to configure the SDMP.js anymore. And we run, of course, it supports the runtime configuration update. And this is SDMP.
Nice. So,
Yeah,
just
that's
to elaborate on that, so that's finishing. So she's talking about reactive routing, but there's also the core SDMP, the proactive path. I finished off the runtime configuration update support for that as well. So it means that you can reconfigure everything about the system without having to restart the whole application. So I think Luke is going to start testing that out with his deployments. Excellent. That's a nice step. Yeah.
Okay, next.
Yeah, it's a must have for
Sure.
deployment, so we're very happy about that.
Yep.
For the M code, we set up the Fabric environment, and the P gateway and the video server already can use Fabric to talk to each other. And between the BBU and the P gateway, there is a cable issue. If we use the ON.Lab cable, then it looks the KVM server can't recognize the link. If we use the cable from KVM, then the Fabric switch can't recognize the link. There's some issue there. And during the OS, there's some manual work about the setup process. Right now, we automated it. And it looks also we fixed the switch, which drops the packet. We still need further testing for the end-to-end to test this issue. And we added some new features in some, the PCI and the PCI automated PCI alignment and the PCI conflict resolution, and the UE assisted neighbor discovery and neighbor list management. But how to integrate the MME XDV and the VF manager with XOS, this one is still in discussion. And because the VF manager it almost equals XOS, so we still need a lot of discussion about this piece. Okay.
Does everyone know what SON is? What's SON?
SON? Self-organizing network.
Yes.
What's that?
Self-organizing network.
Self-organized network. Yes, it monitors the resource of the radio, a lot of details for monitor and organize the network, optimize the network. So this is a page ended by Tom. There are a lot, because we are a huge team, a lot of discussion, the planning going on, like the roadmap towards 5G, and the planning for real-world deployment among the service providers and partners, and the Intel and Ericsson joined us. So next sprint, they will start to contribute something from their perspective. The next 2 weeks, we will have planning about maybe for the next 6 months, I guess. Okay, this is all.
Thanks. All right, it's demo time. Okay.
Okay, great. Is it possible to make me a presenter? I don't know how to do that actually in GoToMeeting. How do I share my screen?
Once it makes you presenter, it'll prompt you to share your screen.
Oh, okay, great.
Once
Terrific.
you're made the presenter, it will prompt you to share the screen. Oh, okay.
Okay, terrific. Can you all hear me?
Yes.
Excellent. Okay, so this is a demo I actually started already of the ONOS.py, and it works, as I mentioned, the same way the ONOS.py did in our second ONOS prototype a couple years ago, actually. Basically, there is a Mininet controller class called ONOS, which will start up an ONOS cluster dynamically on the fly using Mininet. And this is wrapped in a custom file, and so we can actually just use it from the Mininet command line using the mn command, and it will start up an ONOS cluster. And in this case, I have 9 switches, and so ONOS took a while to start up, 90 seconds, which is why I started it up already. But we have a bunch of switches which should be connected to the ONOS GUI. So if we switch to ONOS, we can see our local cluster. And so switching back here, we should be able to run pingall, hopefully. And the hosts should show up, and here they are. And so the goal, like I said, is to have a simple, kind of easy to start up, lightweight, or as lightweight as it can be with ONOS environment that you can just run on your laptop to make it much easier to do distributed ONOS core and application development. And if we shut it down, well, let's see, it'll just shut down ONOS and shut down the network, but we should hopefully be able to start it up with a new network. Let's see. So as I mentioned, there are some issues occasionally with ONOS getting exceptions when it starts up, so we may run into that. I'm going to look at that with some of the ONOS folks like Madan, possibly. So what we've done, or what is created a control network and a data network, and that's kind of important as well because it gives us the capability of doing control network modeling and actually changing the topology of the control network and changing the sort of properties of the control network. For example, introducing delay or even packet loss, turning links on and off in the control network as well as the data network. So waiting for Carafe to boot up here. Hopefully it, well, Carafe has actually started. We're waiting for it to start listening on its SSH port. Hopefully that will actually work. Let's see if we're getting any exceptions. Nope, no exceptions yet. Ah, great, SSH started up. So if ONOS is booting, eventually, since I specified OpenFlow here, it should ultimately start listening on the OpenFlow port. Should be good. This is the last time it took ONOS about 90 seconds to start up, so hopefully this won't be significantly worse. So I think one of the biggest issues of kind of making ONOS usable is to improve its startup speed. But one of the things is that you can't easily improve what you can't measure, and so this ONOS.py provides a sort of easy way of kind of repeatedly starting up, kind of booting up ONOS in different configurations. And so we've started up our switches, going back to, let's see if we can reload it. This is a different topology. Ah, okay. I guess it's I guess it's going to be 3 switches this time. So ping all. Looks good. And here are our hosts. And so that's the demo of, with a simple Mininet command, starting up an ONOS network on the fly. And it took a couple minutes, but hopefully, now that we can do this easily, we'll iterate over it and kind of make ONOS faster and better and make it a lot easier for people to quickly get a distributed ONOS development environment up and running on their laptop just using Mininet. And so with that, we can go on to the next demo.
All right, thanks, Bob. That's excellent. All right, what's up next? I think it's me.
So this is going to be a demo on Buck and maybe a brief introduction, just so you have a pointer for the documentation. Buck build is probably going to be your friend if you're writing rules of your own. Specifically, the rules that we leverage most are, I'll call your attention to 2. One's called Java Library and one's Java Test. Java Library has some parameters that it takes, like sources, resources, dependencies, stuff like that. These are actually wrapped in almost all cases. What we do is we generate a couple of new rules. We add them to the local Buck API. Specifically OSGI jar, which in addition to taking all of the Java library stuff, also will take a name, a group of sources, and then a Maven group ID, version, And then you can also specify the packages that should be imported and exported in a web context. So the import and export packages are OSGI manifest headers that will get auto-expanded. There's also an OSGI jar with tests. So if you automatically want to test one of these things and you have tests in the appropriate location, you can automatically spin up one rule, an OSGI jar and the test for it. And then there's also an ONOS app command that enables you to specify all the stuff that you're used to specifying in the POM XML, app XML, and features XML in one easy-to-use rule that will automatically generate app XML, features XML, and the ONOS OER, application OER. So with that, I guess we can get to the demo. So
hold on a sec, Brian. You went through that really, really fast, and I was not entirely sure what you showed us. Could you just say what you showed us again? It looks like you wrote Buck extensions which allow us to build certain artifacts that are necessary for building a runnable ONOS and its applications.
Sure. So I was actually going to start the build and then talk more about it.
Okay, great.
So
great.
I just wanted to get something started, and then yeah, sure, I'll definitely go back and touch on those. So when you first download Buck, your local cache is empty. So a developer that would build ONOS for the first time would see this. Now, what Buck is doing is it spends the first couple seconds or so going through and parsing all of the Buck files that are provided. You can provide any Buck target that Buck provides, and then there's also some additional targets that ONOS provides that are the ones that we just talked about. So there are special ONOS targets that are not part of the normal Buck API that you can think of as plugins to the Buck API that enable you to build jars that have the appropriate OSGI manifest headers and component description files built in, as well as tests for those OSGI jars, as well as ONOS applications, which are zip files that contain a set of bundles and some configuration files. So in order to generate targets for those three types of things, the OSGI jars, the OSGI jar tests, and the ONOS apps, we have simplified rules that enable you to do that. So Buck will go through all the Buck files in the project, parse them to generate the appropriate targets, and then it will go through the build process where it identifies from a given target. So here's an ONOS pseudo target that is basically dependent on all of the ONOS modules. It will generate a DAG, a directed acyclic graph of dependencies, and then it will run through every job in the DAG, including fetching remote resources, building the jar files, and building the OSGI jars. Here we've got 700 jobs, and it'll run everything that's needed to satisfy the specified target in the command line. Now, if you run it again, Buck will go through and look at all the hashes of all the inputs and realize that nothing's changed, so it can just use the output from.
If you can hear me, that I'm applauding.
So we can do that again. So once you've built ONOS once, if you don't make any changes and the artifacts are in your cache, builds are fast. Now you may want to go and make a change to say an application just for fun, right? Started app, whatever. So I made a code change and we'll rerun the build. It will go through and figure out, okay, well the inputs for some of my build rules have changed. So I need to rebuild the app forwarding thing and be done.
5 seconds.
Now, the thing is, that's a root level one, so there wasn't really much work to do. If you make a change at the API level, there's going to be more stuff that it depends on, but just to show you that Buck will go through and do this, if we add a method here, public, this is an interface, so default void food, and it'll probably need some Java doc. Oops. Okay, and we build this again, Buck will realize that there's a whole bunch of stuff that depends on ONOS API. So it'll rebuild the ONOS API jar, and then it'll rebuild all of the stuff that depends on OSGI as well. So in this case, it's a bit more stuff because you changed an API, but this shows you that making a change to a dependency, even if it's a dependency that's somewhat far down the graph, will result in a correct rebuild. And in this case, we're looking at recompiling basically everything because the API is a top-level target. But what doesn't need to happen again is the re-downloading of the library artifacts. So this build will go a little bit faster than our previous build of 84 seconds and come in somewhere under about a minute. So what do the Buck files look like? So if we look at like the jar that we just changed, ONOS API, this rule here is, as Ray mentioned before, just a Python method call. So there is a plugin called ONOS API jar with tests. We're going to give it a name of ONOS API, and then we tell it what the compile time dependencies are for this rule. So it's libcompile, which is an aggregation, a special aggregation target that has a bunch of third-party dependencies, as well as ON.Lab miscellaneous, ON.Lab OSGI, and ON.Lab REST. If we wanted to look at another rule, like for the REST API, for example, it has some different dependencies. It also has special test time dependencies, and it has a web context because it shows up in the UI, or rather via the Jetty server. So these are sort of what the rules are going to look like in the Buck files. Instead of editing a POM file, you'll edit a Buck file. If we wanted to look at an applications Buck file, we have the same thing, OSGI jar with tests. This one, note, doesn't even have a name. The name is derived from the file system. So this ONOS apps forward would be the name of this target. You can put one in if you needed to or wanted to, but it's automatically filled in. The idea is that we have defaults that are sensible based on the conventions that we've largely adopted from Maven, but everything is overridable if need be. So you build one jar which contains the application code, and then you have the app specification, which is, again, another Buck rule that takes title, category, URL for the application and description. And then you can look at some other ones. In general, we try to make these simple. So this is the specification for the DHCP app, specification for the DHCP API. So these files get really small if you use the conventions and the DHCP implementation. So the next thing to do is to run this. So for now, there's a special target called install, which will stage these artifacts in the M2 repo. This is kind of an inefficient way of doing it, and it's mostly because it was the path of least resistance. As we mentioned before, we plan to do a better job with staging, both for packaging and local deployment. But for now, we spend about 20 seconds installing all the artifacts into the M2 repo. And then once they're there, we can start ONOS. So this hopefully, incrementally will get better. But ONOS will start. You can see that a lot of the features that we've built, API, GUI, whatever, they're all starting. And we can hit the GUI. Like so. And if we want to, say, install one of the applications we've built, like the forwarding application, reactive forwarding, we'll just trash it here. and then what we can do is say ONOS app localhost install. So this is the standard command you're used to seeing. And then the location of where Buck puts stuff is in a directory called buck out. So gen, and then it's the path which contains the rule. So in this case, it's apps fwd, and then the target name, which is ONOS apps forward, and then we want the OER file, application OER. So this is the Buck built reactive forwarding application. We get back a affirmative active from the REST API. And then if we look in here, we can see that reactive forwarding is active. And if we wanted to start a topology and see if we can ping, that works. So as we mentioned before, there's still some work to go. But in terms of initially getting the product built, oh yeah, and tests too. So we'll run the tests. One cool thing that Buck does is instead of running the tests serially like we do in Maven, Buck will spend a couple of seconds building all of the tests for the whole project. And again, this just happens really the first time you download the source tree, and then every time you change. And then it will run all of the tests in parallel. So you can see right now, I think it's using 8 different executors. And you can see in each of these lines what test it's currently working on. And then it'll print a report at the end with all of them.
The default behavior is it uses 125% of the number of cores you have. That's the number of threads. So on our laptops, it tends to run 6, 7, 8 in that neighborhood. This is just a huge win compared to Maven. Because, as Brian was saying, Maven not only does all the test directories sequentially, it does each of the tests themselves sequentially. And you can see it's done already. It's run like 3,500 tests or something that we have in the system.
So the build output is here. So it takes a couple seconds to build the tests, and then about 40 seconds to run all of the tests. And the interesting thing about Buck, like we said before, if the inputs don't change, the rules are expected to be deterministic. So if we rerun the tests again, it's going to go through, see if there's any compilation changes, which tests could be affected by those compilation changes, and then rerun the tests that are affected. So it's done already. You notice that for the test that it's decided nothing's changed, it writes cached in front of them and just uses the cached test result from the previous run. So the idea with this new build framework is that our rules are ideally going to be a lot more deterministic, and dependencies are explicit. So if you don't change something, it doesn't need to do it again. And if you do change something, the idea is that you can be confident in the build tool to pick what needs to be redone.
I have one case I run into before. I want to share with you. So we have some potential issues. So the issue was when I run the OpenFlow UT test. So some testing case they take longer times.
Mm-hmm.
Okay. So the later on, once you run the second round, so the time span is changed. So if you run again, they will change it again. So seems like the more round you run the UT case, now you find each times the time spent on each UT case is totally different. So if we go there, so not change the case, we cannot find how can we figure out the debug the issues, because you always use a previous cache, right?
Okay, so if the idea with the build is that you hash over all of the inputs. This includes all of the inputs to the build target rule. So if we look at a build target, like forwarding, forwarding is an example. So OSGI jar with tests will put in some defaults. So a hash over all the defaults and the explicitly defined rules is done. And this includes any files that you have as well. So if you, for the purpose of building, if you don't change anything on the input side, you shouldn't expect anything to change on the output side. Now, if one of your rules has non-deterministic behavior, you basically have to inject some entropy into the rule definition. You can just generate a random number, put it in as an input, and then it will force that rule to rerun every single time. But I would argue that that might be sensible for debugging, but really it shows you an error in your test or your target or your build rule. And we should work on fixing that so people don't have to rerun these things every time.
Okay.
But for example, the rule to install into the Maven repo, the Maven repo can get clobbered by other things, like fetching from the remote repo, or it can get clobbered from the local install, like a Maven-based install. So we actually inject some entropy into the Maven install rule so that it always reruns.
Okay.
So if you run install, it'll always do the running of those rules. The idea is that we'll eventually fix that rule so that we'll stage the artifacts in a different place and we won't need to do it. But that's sort of the mentality that people should start thinking about. And the idea is that we don't want to have to redo the same thing every time when you haven't changed anything.
Okay. So the second question is when the code is not changed when you build. So the jars, the timestamp is the previous one, so it's the new one.
Timestamp doesn't matter. Well, the timestamp is new, I think.
Is it new?
I don't know.
Yeah, I think
It doesn't look at timestamps, so
I don't care. Buck doesn't care.
Box doesn't care, but the jar files is the new timestamp.
I don't know.
I think it's the old timestamp because I think it doesn't even touch them. It just says they're okay. I don't have to do anything. Buck doesn't look at that.
Yeah. So so I think what's a couple of things is clear. One of the things is that we're going to be rolling more and more Buck functionality out into the source tree. So when you see those files, feel free to take a look at them if you want. We're not yet there 100% on terms of being able to replace Maven one for one. And so the official supported way of doing the build is still Maven for now. When we get to a point where we have 100% coverage in terms of all of the artifacts, all of the OER files, Swagger, everything else, I think we'll do another session that's just focused on Buck. And we'll talk about questions, we'll try stuff out, and we'll also hopefully have a little bit more documentation that people can play with as well.
Yeah, okay, thanks.
This was more of a progress update than an introduction, which I think I took a little bit too much time on. So, yeah,
It was excellent.
it's great.
Yeah, it's great. I probably asked too many questions.
It will improve quality of life in general.
Oh yeah. Thanks. All right. Who's next on the list?
Yes. Okay. Before I go through in detail of this demo, I will briefly give some introduction, some architecture stuff of this control plane monitoring stuff. So basically, it tried to monitor control messages at first. So it monitors 6 type of control messages, and they store in locally in a one Ruby database. So it only store one day historical data of all the matrices. And second thing is also take some external system matrices, CPU, memory, those kind of stuff from third-party monitoring tool. So for this demo, I'm using the collectd to report all the system matrices. And these kind of metrics will be eventually reported to third-party like a monitoring server, something like Ganglia or InfluxDB or Graphite, whatever you want. And that will be visualized by the third-party like Grafana, like graphing tool. So the end user can see what is going on inside the ONOS and so on. So this is a brief introduction of this control plane monitoring. So I will show some demo about that. So now this is the shows what I'm running the control plane monitoring tools. So now in order to run this, you have to enable this CPMan and as well as the influx database metrics. So these are all implemented by myself, and these are the share logs and so on. So I will show how this has been reported. So in order to see what kind of metrics has been reported to influx database, you just simply type. Here is some kind of so measurement, and it will show you. Oh, sorry. So you need to check the database as ONOS and select to show like the measurement.
So is the collect the database itself, or is that just a tool that?
It's just time series like a third party.
Time series data. So it's
Yeah,
not SQL data.
Yeah. So it's not SQL, and it support the clustering as well. So it's a distributed database. So if you can see, it report a whole bunch of ONOS like related metric data, and you can see a whole bunch of stuff. And since there are so many data has been like reported, we have to selectively choose a certain part of data to visualize. So for that purpose, I also installed Grafana. This is a third-party monitoring like graphing tool. So I generated a set of dashboard for visualizing the cluster communication messages and so on. So if you click on one, so those are all the configuration what I made. This is just a simple one. So you can see the whole bunch of matrices being just plotted like this, and you also can choose whatever kind of style they want to plot and so on. So it can be very easy to visualize what's going on inside ONOS. So those are ECM is eventually consistent map like configuration like the messages exchange between two like ONOS instances, and also there are eventually consistent map like ONOS like messages as well. So you can also select one of it like click on just one to see just one trend of a certain matrices as well. So that's it. And I can go through more detail, but okay. So this is a consistent map invocation like a map. So you can see it's pretty much almost same, and you also can see control message set for all devices. So like this, it's almost like similar, but you somehow can see how many number of like packets or how many bytes has been like transmitted and received per by a certain instances as well. You also can specify what kind of instance you want to monitor as well. And also, you can take a look at the system matrices like CPU load and the memory usage, as well as the NetWire, disk I/O. So that is the VM stats that runs on those instance. So you can see pretty much what is going on under the section. So this is my demo. So any question?
Yeah, Jen. So going back to your previous sort of graphs of statistics from within ONOS, what kind of insight do you derive from these graphs?
What kind of graph you are mentioning? This one?
Yes. Well, here's an example, right? So like, there are a bunch of interesting graphs, but it's not clear to me like what they mean or what sort of insight you get from this. What does this tell you? Does this tell you something useful, and how would you know that?
Okay, so these are all the number of messages being exchanged between the ONOS cluster actually. So this is kind of useful for debugging what is going on in a ONOS cluster. So once a certain message has been there's a huge number of messages being generated by a certain like node, we can easily can detect that kind of a phenomenon by using this kind of graph as well.
So Bob, in the past we have found it very useful to basically look at metrics like this to highlight anomalous behavior. For example, there were times when we were unexpectedly making too many operations on a particular consistent map due to a bug, and having access to these kind of metrics helped us quickly identify where that was happening.
But okay.
That says that's a great job. So I'd love to see if I can apply this to like recording some of that information up through the Ceilometer or Monas.
Yeah, sure. I already implemented the REST API for exposing all the metrics. So I can show you the API how you can get those kinds of metrics outside the phone. Sure.
Yeah, we probably should have separate meeting.
Yeah, sure. Yeah, no problem.
Do you have a tutorial for setting this all up?
Yeah, I already wrote some kind of like a tutorial for this in the wiki. So, but I will. Some part has not been done yet. I will add more like contents, and help the QA guys to see what's going on inside ONOS.
Yeah, wonderful.
Yes, that is very good.
Yeah, very nice. Thanks. All right, cool. All right.
And collecting is open source and graph
It's all open
everything
source.
shown as well.
It's all open source.
You.
So I terminate.
Have you done already an integration with Nagios or?
If you just figure it out, you can try. You can try that as well. But I don't know.
Okay, so theory designing show test. Since show test is expected to run for several days or longer, so we want to bring more scalability and flexibility into the test. For example, we may want to do some debugging when the test is running, or we may want to change the test configuration or even the test logic in real time. And we may also want to run some test cases in parallel. So, however, the old show test can only run a predefined list of test cases. So, this is why we want to introduce a chaos monkey style show test. We call it show test monkey. And this is the framework of the show test monkey. We abstracted all the test logic from the old show test into different types of events. So each test event stands for an atomic test logic, such as installing an host intent or bringing down a link or check some ONOS status. So basically, we have four event families, including check event, network event, application event, and ONOS event. We have several ways to inject the events into the test. First, we can still use the promise file to predefine a list of test events. And also, now we can inject arbitrary events from external script or use the CLI of the show test monkey. And under the hood, we have the event listener for the events from triggers from the outside. And the event listener will call the event generator to generate different types of events. Once the events are generated, they will go to the event scheduler and go from the pending event to the running event. Of course, we can implement different scheduling methods. For example, we may want to run some events in parallel, and for some other events, we may want to run that event until all the other events finish. One scenario is that we may want to finish all the checks before we trigger the next failure events. So also we can also reschedule the events when they fail. As this demo. So now show test monkey is running a predefined list of events in the prompt file, including installing all the host intents and bring down some links and bring up the links, and then uninstall all the events. So this is CLI. We can inject any kinds of events at any time. For example, when we want to start to check the topology, and the event will go to the tail of the pending event list. And if we see some errors or warnings, we may want to pause the event to do some debugging, and we may just type pause test. And after all the current events finish, the test will pause, and then we can do some checks. For example, check intent, or we can also bring down links. And oh, sorry, it's already down. Yes. Z2. Yeah. Oh, okay.
Z2, Z2.
Thing. S2. Yes, and then we can check the topology and see that the topology is correct. We now have 4 links. So then we can resume the test. Oh, sorry. After we finish the debug. That's it.
Right. It helps on a lot of efficiency where we're actually in show test, we see a lot of values to replicate it and like the dosing installing state, and it's very difficult to try to make it into a state that keep up the physical help a lot.
All right. Thank you.
Okay. So the goal of this short demo is to show that now ONOS can discover the BMV2 switch and breakpoint information. To do so, I implemented a set of drivers that use Thrift-based interface and protocol. For who doesn't know, like Thrift is basically a remote procedure call protocol. So it's, this case it's ONOS to switch communications. So application, we have now BMV2 device drivers, BMV2 provider, and also enable the driver supermetrics to show you that right now for the BMV2, we implement the flow reel programmable to install flow reels, even if I'm not gonna show this today because of some bugs, and the port discovery. So we'll go back to the topology here. So now I have ONOS running and a Mininet machine where I install my P4 environment with BMV2. So I'm gonna start a very simple topology that comprise only one switch and two hosts. In this case, to start the switch, I'm specifying the interface the switch is gonna use the Thrift port for the server, and very important, the JSON specifying the pipeline, okay, that the switch has to implement. I'm gonna start also some logging to see that the switch is running, and we have now 2 ports on the switch. And to discover the device, I said before, because Thrift is an RPC protocol, there's no way right now for the switch to, contact the controller and basically say hello. So we have to manually tell ONOS that there's a BMV2 switch, and to do so, we use using the netcfg subsystem. This is an example of configuration. So basically, you say what's the IP and the Thrift port to use. Inject this information, and voila. Switch is here. It's P4.org switch is actually the vendor, because it's part of the P4.org open source development. And we can see that the switch has 2 ports. And I hope you enjoyed the demo. I mean, I really wish to show you how to install flow reels, because that's the cool part. But hopefully, I'm gonna solve this problem with Android today. I think debug this. But at least we now ONOS is aware of new type of device.
Yeah. Very cool. Nice set of demos.
A lot of demos.
Yeah. Some really great demos. Best demos we've had in a long time. All right.
2 minutes to launch.
So, anything else?
We're on time.
That's it? Okay, cool. Thank you, everyone. That's the end of the meeting.